What if I told you that the strangest object ever to enter our solar system has just crossed a line no astronomer expected, and what it's doing right now is forcing scientists to question whether the physics we trust is even complete? Stay with me, because what you're about to hear isn't just unusual, it's unprecedented. And once you see the full picture, you'll understand why the astronomical community is more divided, more shaken, and more fascinated than at any time since the discovery of Oumuamua. Imagine this, a faint glimmer on a survey image taken in the early hours of a quiet night in Chile. Nothing unusual, nothing remarkable, just a speck. But that speck, later confirmed as 3 Interstellar Atlas, 3I/Atlas for short, would soon become the most confounding cosmic visitor humanity has ever observed, the 3rd confirmed interstellar object in history. A wanderer from beyond the sun's domain, a messenger whose behavior would rip open every assumption we thought we understood about icy bodies drifting between stars. At first, astronomers were thrilled. Another interstellar traveler, another chance to study something forged in the chemical furnace of another star system. But as telescopes locked onto it, something immediately felt off. It wasn't its brightness, it wasn't its trajectory, it wasn't even the fact that it was shedding gas and dust like a standard comet. No, it was the sheer quantity of what it was shedding. When the James Webb Space Telescope turned its infrared vision toward it, the readings were unmistakable. A massive sphere of carbon dioxide surrounding the object, so large, so bright, and so chemically bizarre that no one could quite explain it. This wasn't the gentle halo of a typical comet warming under sunlight. This was a storm, a ghostly globe of activity stretching farther than the distance from Earth to the Moon, pulsing with unusual compounds, irregular chemical ratios, and spectral fingerprints that didn't line up with anything in our cosmic catalog. And then the first anomaly hit, the acceleration. Comets accelerate all the time from outgassing, but 3I/Atlas wasn't behaving like an object being nudged by sunlight. It wasn't drifting, it was surging. A sustained, continuous directional push, stronger than predicted, stronger than modeled, and strongest exactly when it shouldn't have been. The acceleration increased as it neared perihelion, almost as if the object were responding to the sun itself, not passively, actively. Even stranger, the object began to change color, first subtle, then undeniable, a deepening blue that defied standard cometary physics. Comets don't turn blue, not like this, not naturally, but the reflectance curve was shifting inch by inch, as if the compounds on its surface were rearranging, transforming under some internal pressure we couldn't see. Something was happening inside 3I/Atlas, something building, something ready to give way. Astronomers watched, puzzled, intrigued, and slightly uneasy. Every hour delivered new data, new inconsistencies, new contradictions. The trajectory fit an interstellar object, the chemistry did not. The mass loss matched a disintegrating comet. The geometry did not. A pattern was emerging, one no single model could explain. Then, in late October, the event happened. A sudden spike in brightness followed by a sharp drop, a flutter in the spectral lines, a burst of high-velocity material streaming off the nucleus, and then the object split, violently, decisively, catastrophically. 16 fragments, at least 16, ripped from the core, scattering into a loose formation that expanded with each passing hour. The initial assumption was obvious. The object had broken apart like any overstressed comet nearing the sun. But the deeper astronomers looked, the stranger it became, because the fragments weren't drifting randomly. They weren't scattering chaotically. They weren't behaving like debris at all. They were accelerating too. A single comet nucleus could not account for the staggering mass loss rates being measured from Earth and space-based telescopes, but a constellation of fragments, each with its own surface area shedding mountains of material every second, that changed everything. Suddenly the numbers made sense. Suddenly the physics aligned. Suddenly the runaway eruption of gas and dust had an explanation. But that explanation carried a deeper question. What could cause an interstellar object to rupture so violently that its pieces were still shedding material at rates thousands of times higher than any comet we've observed? Harvard astrophysicist Avi Loeb published the first calculation suggesting the only scenario compatible with the energy output was a full structural failure, something inside the object giving way, splitting it from the core outward, releasing a shockwave that rippled into space. But even Loeb urged caution. The numbers were real. The physics was sound. Yet something about the fragments bothered him, the organization. Because days after the rupture, British astronomers pointed their instruments toward the reappearing object and captured something that sent chills through the entire research community. Jets, multiple jets, long columnated jets stretching millions of kilometers across the void, one pointing directly toward the sun, an anti-tail, something that should never happen, something that defies solar radiation pressure, something that should be impossible without a tightly controlled outflow of material. And then there were the other jets, dozens of them, aligned, structured, geometrically consistent across multiple fragments, not chaotic, not drifting, not random, coordinated. The word no astronomer wanted to use. The word that transformed 3 Interstellar Atlas from a scientific anomaly into a cosmic cliffhanger. Because if these fragments were natural, they should behave independently. They should cool. They should disperse. They should fade. Instead, they grew more active, more organized, more synchronized. Jets brightened. Anti-tails sharpened. The entire formation behaved less like debris and more like a system responding to something near its center. And then for just one moment, telescopes in the southern hemisphere caught a flicker from deep within the corridor of fragments, a pulse, a brief spike of radiation, not a star, not a rock, not ice, something else, something unknown, something that glowed and then vanished. A signature with no match in astronomical records. Scientists paused, debated, whispered. If something lay at the center of that formation, if something were interacting with the fragments, if something were influencing their motion, then everything we thought the breakup explained might only be the beginning of a deeper mystery. And as 3I/Atlas continued its journey, still accelerating, still shedding, still forming impossible structures, a final question rose above all others. What exactly entered our solar system, and what or who set it free? By the time 3 Interstellar Atlas emerged from behind the sun and slid back into visible skies, astronomers around the world were ready, eager even, to finally understand what they were dealing with. But the moment the first new images came in, the curiosity turned into disbelief, because instead of seeing a fading cloud of debris drifting aimlessly, telescopes captured fragments that were brighter, sharper, and impossibly organized. Jets were streaming from multiple points across multiple shards, forming lines and angles that should never appear in nature, anti-tails cut directly toward the sun, as if the fragments were ignoring solar radiation pressure entirely. And then came the symmetry. A shape, almost architectural in its precision, began to form across the swarm. No one said the word out loud at first, but everyone saw it: a framework, a pattern, a structure hidden in motion. The first team to publish their observations described it carefully, almost nervously. The jets appear collimated and aligned, exhibiting directional coherence across independent fragments. Translation: the pieces were cooperating. The pieces were behaving as if they were responding to something larger than themselves. Meanwhile, Loeb recalculated the mass loss. If the fragments were natural, the energy required to power the jets at their observed brightness should have been impossible. A normal comet would have run out of material in days, but 3I/Atlas wasn't slowing down. The jets were intensifying, the gas halo was expanding, the radiation spikes were continuing. Something was feeding the system or sustaining it in ways no natural mechanism could justify. And that was when the fragments began to drift into trajectories that broke every simulation. Not chaotic spirals, not diverging paths. Instead, they curved gently, deliberately, almost as if orbiting an invisible point at the center of the formation. The coordination stunned everyone. Fragment 3 and Fragment 7 accelerated in near-perfect synchrony. Fragments 9, 11, and 12 released jets in parallel, creating glowing blue-white plumes that lined up with an angle astronomers measured at nearly identical degrees. These were not random occurrences. They were too synchronized, too precise, too rhythmic. But then came the observation that truly rattled the community. The fragments weren't just reorganizing, they were converging, slowly at first, then faster, their paths tilted inward, bending toward a region of space where nothing was visible, nothing bright, nothing massive, nothing that should exert any force at all, yet something was pulling them in. At the Cerro Tololo Observatory, a technician monitoring the automated pipeline noticed something odd, a faint dip in the light curve from the region where the trajectories were converging. Not a flash this time, not a spike, a dip, as if something dark, something barely reflective, were briefly passing between the fragments and our line of sight. When the data was cross-checked, the dip appeared again. Different night, different angle, same location. Astronomers hesitated to speculate, but privately, discussions turned toward the possibility that something was at the center of the formation, something small but powerful, something unseen, something controlling or influencing the motion of the shards. Theories exploded across internal research groups. A compact dust mass? Impossible. There was no reflective signature, a remnant core? No. The spectral lines didn't match. A magnetic anomaly? No natural comet remnant could generate the field strength required. Days later, a new set of images revealed yet another twist. Thin streams of material, almost like filaments, began stretching between some fragments. Faint, delicate, shimmering lines connecting shard to shard. They appeared only under specific wavelengths and only for minutes at a time before dissolving again. But what they suggested was undeniable. The fragments might not be separate bodies anymore. They might be interacting. This wasn't a debris cloud, it was a system. And then, as if the universe wanted to complicate matters further, the fragments changed color again. The blue deepened. The reflectance shifted toward shorter wavelengths. Spectrometers detected more metallic signatures, traces of nickel, iron, and carbon-rich compounds arranged in patterns that didn't match typical comet dust. Even the ratios were wrong. Too balanced, too stable, too intentional. The jets themselves pulsed, softly but rhythmically, like breathing. The timing was irregular, but the intervals between pulses aligned across multiple fragments. Every few minutes, multiple jets brightened at once, then dimmed, then brightened again. When observatories compared timestamps, they realized the pulses were synchronized to within a fraction of a second. A natural comet doesn't pulse in unison with its own fragments. By now, even astronomers who had spent their careers debunking sensational theories felt an unease settling over them. A veteran researcher at the European Southern Observatory described it bluntly. "I don't like what the data is implying." Another put it more poetically. "It's behaving like it remembers being one object." Eventually, the question everyone tried to avoid resurfaced. What broke 3I/Atlas in the first place? The official assumption was thermal stress near perihelion, but the fragments were accelerating in patterns inconsistent with an outward explosion. Instead of moving away from a central blast point, several shards appeared to be moving back toward it, as if the rupture wasn't an accident, but a transition, as if the breakup was step one, as if something inside needed the shell to crack open. Even more disturbing were the temperature readings. Using infrared narrowband filters, telescopes detected localized heat pockets on several fragments. Temperatures too warm for simple solar heating. Something was generating heat from within, not enough to glow visibly, but enough to register as a thermal anomaly. The idea that began to take shape wasn't spoken in public, but it crept through private channels. What if the object wasn't breaking down, but activating? The deeper astronomers looked, the more the data pushed them toward interpretations they didn't want to consider. Stable acceleration, coordinated trajectories, jets functioning like directional thrusters. radiation pulses with consistent intervals, a formation behaving less like debris and more like a reconfiguring machine. When the third radiation spike hit, stronger than the first two, spanning nearly 5 minutes before fading into silence, the narrative changed again, because this time the spike wasn't random. It repeated precisely 11 hours later. A period, a cycle, a timing pattern. Radiation spikes don't run on schedules. Natural objects do not adhere to timetables. Something was happening inside the cluster, something systematic, something intelligent, or something following instructions left long before it entered our solar system. And as the fragments tightened their arcs, closing in on the invisible point between them, the world's telescopes all turned toward the same question: what is waiting at the center of 3 Interstellar Atlas? As the fragments of 3 Interstellar Atlas spiraled inward, telescopes around the world captured their slow, deliberate convergence. What had begun as a chaotic-looking breakup was now unmistakably organized. The shards weren't drifting. They were aligning, turning toward a single invisible point, as if answering a silent command buried somewhere in the dark. And then, in the early hours of November 18th, something changed. The jets dimmed, the pulses slowed. The glow of the fragments softened into a strange, synchronized stillness, like a constellation holding its breath. For nearly an hour, nothing happened. No jets, no flashes, no radiation spikes, just 16 quiet, drifting pieces hovering in geometrically precise positions. Some astronomers compared it to a frozen mechanical assembly. Others said it looked like a broken machine finally ready to reveal its purpose. But whatever it was, no one expected what came next. At 4:16 UTC, a faint shimmer appeared at the center of the formation. Not a flare, not a pulse, a shimmer like heat distortion above a desert highway. The distortion expanded, warping the light around it, bending the faint starlight behind it. Observatories scrambled to recalibrate, assuming a technical glitch. But it wasn't equipment, it was real. The distortion sharpened into a curved outline, something spherical, something smooth, something that reflected almost nothing at all. A gravitational lens? Too small. A dust cloud? Too stable. A remnant core? Too perfect in shape. The sphere widened into view, as if emerging from a cloak of invisibility. No sparks, no jets, no light of its own. Just a silent, shadow-like object, smaller than a comet, but larger than any fragment, suspended exactly at the center of the converging swarm. It floated there, absorbing nothing, emitting nothing, simply occupying space with a presence that felt impossibly deliberate. Across the world, scientists froze. Some whispered, some cursed, some just stared at the data, unable to look away. Then the fragments responded. One by one, each shard released a short, sharp burst of dust like a final exhale. Their jets flickered back to life, not in chaos, but in sequence. Fragment 3, then fragment 11, then fragment 7, a cascading ignition circling the sphere in a pattern too rhythmic to be accidental. The jets formed a rotating lattice of blue-white plumes, spiraling like petals around a hidden core. For a moment, it resembled a blooming flower forged from ice, dust, and interstellar metal, and then the jets aligned downward. Toward the sphere, the shards began to descend, sinking slowly toward the central object like satellites falling into their intended orbits. Each fragment matched speed, matched angle, matched timing, as if following a choreography older than our sun. And just when the pieces began to overlap, their silhouettes dissolved, breaking apart into clouds of microscopic dust that wrapped around the sphere in glowing layers, 16 layers, 16 shells, 16 remnants merging into a single shape, not a comet, not a debris cloud, something else entirely. The sphere brightened, not with light, but with structure. Lines appeared across its surface, faint metallic seams glowing with a cold blue luminescence. The dust settled into them, filling the grooves like circuitry, awakening for the first time in millennia. The object pulsed once, a deep resonant tremor that shook the entire formation, and every observatory on Earth recorded the same thing: a narrow spike of radiation, perfectly uniform, perfectly timed, perfectly controlled. It wasn't random. It was a signal, but it wasn't sent to us. Because as the sphere completed its transformation, the jets shut down, the dust settled, and the object, whatever it was, rotated with a precision no natural body could achieve. Its motion was steady, flawless, mechanical. It aligned itself with the direction of its incoming trajectory, reorienting toward the outer solar system as if preparing for departure. For 6 long seconds, it remained perfectly still. No jets, no radiation, no movement. And then it accelerated, not gradually, instantly, a silent burst of motion that left a glowing wake across every telescope frame. It shot forward with a speed that defied sublimation, gravity, and every known force that could act upon a solid object. Within minutes, it had cleared its fragment cloud entirely. Within hours, it had traveled farther than any comet ever recorded at that stage of orbit. And within a day, it was gone, vanishing into the black beyond Jupiter's orbit, accelerating toward interstellar space with no signs of slowing. Astronomers didn't issue a statement. Not immediately. What could they say? That an interstellar object entered our solar system as a fractured shell, self-assembled around an invisible core, activated, and then left with purpose. The official reports will come later, carefully worded, carefully measured, carefully restrained. But for now, all we know is this: 3 Interstellar Atlas was not what anyone thought it was, not a comet, not a fragmenting ice ball, not an interstellar tourist. It was something older, something engineered, something designed for a purpose we can only guess. And whatever that purpose was, it didn't finish here. It only began.